All right, so today let's look at the surface area of pyramids. And surface area means if you were to wrap up this pyramid with some wrapping paper, how much area would it be required to cover the entire surface? One of the most common or popular pyramids are called regular pyramids. Regular pyramids are pyramids that have the base as a regular figure, meaning a figure that has all sides the same, like a square. So a square-based pyramid is a regular pyramid. And I'll do the best I can to draw this. Okay, so that is a square-based pyramid because a square at the bottom is considered a regular figure. All sides are the same. And if I were to, let's say, open up the tip of this pyramid and let all the sides flatten out, this is called a net. A geometric net is the figure before it's been built into a three-dimensional figure. Not drawn to scale, but you get the idea. So that would be the net of this figure, meaning if I were to pick up all of these triangles and stand them all up to one common point, it would make that pyramid, okay? And there's some vocabulary that go along with this. And in a pyramid, we have the height of the pyramid, meaning how tall the pyramid is from the center to the top. But when we're talking about surface area, we're not worried about the inside of the pyramid. We're worried about the paper required to cover this pyramid if it were to be a pyramid-shaped box or enclosure. So what we're going to do is we're going to call this a slant height. And that's the height that is relevant to us right now because that's the triangle that's going to get covered up with wrapping paper, right? So for say, if we were to try to find all of that surface area. And if it's on a net like this flat on the paper, then this would be your slant height. And the reason it's called a slant height is because it is actually slanted, resting against that face of the pyramid. And then we have the entire area of the base. Okay, and that base, so when we're talking about the base of the pyramid, it's the entire square at the bottom, okay, not a linear distance. And then when I'm talking about the slant height, it's going to be the height of the side triangle. All right, so surface area is going to be the sum of all the areas of the base and lateral faces. All right, so the sum of all the areas of the base and the lateral faces. So when we're doing this, we are going to have to add up the base, and these are called the lateral faces. So let's just go ahead and write that down. Lateral faces. Lateral meaning that when they stand up, they're going up and down. Latitude, longitude. All right. So let's look at example 1. So let's look at example 1. We're given a pyramid. They said it's a regular pyramid. And we got All right, so example 1 is a regular pyramid, and it's got a lateral height of 8 inches, and it's asking me to find the surface area of the regular pyramid. Now, why is it important for them to tell me it's a regular pyramid? Because they didn't give me a length and a width. They only gave me one dimension, which was 5. But because I know that a regular figure means all sides are the same, then I can also conclude that the other side is going to be 5. Okay. So if I were to draw this out, some of you need to see this visually. It would look like this. I got my 4 triangles on each side and my square in the middle. It's kind of sloppy, but it'll do. And the base we know is 5 by 5. And then we know that this height here is 8, which is the same as all of these. Now we don't need to do all of them because we're just going to end up multiplying them by 4 because there's 4 of them. So the surface area is going to be equal to the area of 4 triangles plus the area of 1 square. Okay, so these 4 triangles are the lateral surfaces plus the area of the square, which would be the base. So let's go ahead and do that. Area of 4 triangles. 4 times 1 triangle of these would be base, which would be 5, times the height of 8 divided by 2, plus the area of 1 square, 5 by 5. That's 25. And now we're just going to make this 40 divided by 2 is 20, and 20 times 2 is 80. This is 40 divided by 2 is 20. 20 times 4 is 80 plus 25. So that's going to equal 105. And the units were inches squared. We're not talking about volume, although it looks like it's a 3-dimensional figure. We're actually only caring about the flat surface area. Wrapping paper does not fill up anything. Wrapping paper is flat, so it's a 2-dimensional measurement. All right, so let's look at example 2. Find the surface area of the regular pyramid. All right, so this time our pyramid has a triangular base, and it is still a regular pyramid, so it's an equilateral triangle. So let's draw this kind of big because we're going to have to label some numbers in there. So draw your triangle big enough where you can label things inside. So on our base, we have a triangle. And the side lengths are going to be 10. Not drawn to scale, but because I know they're regular pyramids, all of these are going to be 10. And they're also telling me that the side, or the slant height, is going to be 14. And then they also tell me that on the bottom, we got a triangle on the base, and that triangle on the base has a height of 8.7. All right. Now, let me outline this triangle so you can see with all those lines it doesn't look so bad. So the green is my triangle. I'm sorry, my pyramid. Okay. And all the other lines are measurements. Now, if I were to collapse this pyramid into a flat net, it would look like this. Equilateral triangle on the base. That's this bottom triangle. And then all of these three walls would collapse and fall flat down. 1, 2, 3. Not drawn to scale, okay? Doing my best. Now, given that we have all these measurements, we're going to label it on our net. So I know that this is an equilateral triangle on the bottom, that each side is 10. Okay, and then I also know that each lateral face has a height of 14. And then I also know that the base itself has a height of 8.7. Now, because it's an equilateral triangle, I can go from here to here, or here to here. It doesn't matter. I'll just say this one I know is 8.7. Okay, so hopefully you can follow along with all my labels. And those dimensions are going to be important when we're trying to find the surface area. And remember, surface area just means if I were to create this figure out of construction paper or cardstock, how much area would I need? Or if I'm going to wrap up this pyramid, how much paper would I need to wrap it all up? It's just the outside areas, nothing to do with the inside filling. So surface area, the plan is to add up the area of the base, and then we're going to add the area of the three lateral surfaces. So once we got the base down, we got to add these three triangles. Three lateral faces. All right, so let's go ahead and write out the math calculations for those. And I would say that surface area equals area of the base. Now we're going to use the triangle formulas, which are going to be base times height over 2. And in this case, because I have three triangles, it's going to be 3 times base times height over 2. Okay, so let's go ahead and do just the base. Base would be 10 times height 8.7. So 10 times 8.7 over 2 plus this triangle formula is for the lateral faces. So they all have a base of 10 and a height of 14. And the formula says to divide it by 2. All right, and now this here gives me 43.5 plus, that's 140 divided by 2 is 70. And then I end up with 43.5 plus 210, which equals 253.5 meters squared, because we're talking about area. All right, and there you go.